Hello and welcome everyone to the SCOMathon 2021. My name is Dujon Walsham. I am a system center architect for my own business named Walsham Solutions Limited. So myself and Walsham Solutions Limited, we specialize in pretty much the whole of the system center catalog. So everything from SCCM and now also SCOM, as we will be covering the alert enrichment workflow, which is quite becoming a very common approach to SCOM in a lot of organizations. So we will be covering a lot more of the alert enrichment workflow, everything from top to bottom to everything and how it works. This is a a workflow and a solution which I've put in various projects over the years, specializing in SCOM all the way from realms of SCOM 2007 all the way up to SCOM 2019. Just to cover the agenda, we will be going through what is the alert enrichment. We will also discuss in more detail on how the process works and how everything comes together. We will also cover everything from what information can actually be enriched when we look at our alerting data. We'll also be covering the alert mapping process, so how we actually structure the alert enrichment workflow and where everything will be mapped. We'll also cover the more of the back end side of how the failover will actually work whilst the alert enrichment workflow is actually running in place. We will also go through the enrichment workflow in terms of the structured piece of how everything is processed and how everything starts, and then to how the alerts are then eventually enriched and then showing in great detail within your SCOM console and the overall SCOM solution. We will also show how the actual workflow is then encapsulated in a customized management pack, and then we will provide just a short demo just to give an idea exactly on how the alert enrichment works and how you would actually see it materialize in your SCOM console. So in terms of SCOM, how do I see SCOM? So SCOM, I believe, is a monitoring solution that can pretty much monitor anything and everything. But in order to unlock all of those attributes and all of those abilities, it then takes a lot of thoughts, a lot of design, and a lot of structure as well. And when we put those types of thoughts and designs and ideas together, we can pretty much allow SCOM, the actual monitoring solution, to be structured and to be able to achieve anything possible in terms of a business requirements and then providing an actual technical solution. So with that being said, one of these technical solutions we will cover in detail will be the alert enrichment workflow. So what is alert enrichment? So basically, when we have alerts that come into SCOM, when it comes to either people such as business stakeholders, or you may even get first line support teams or any kind of support teams that may deal with the normal triaging of alerts, you'll find that sometimes some alerts in SCOM may not always cover a great detail of information. So you may not actually fully be aware of what is actually affected in SCOM and how it affects and how it relates. And you also may not be aware of the actual domino effect which a particular alert might entail. So, the alert enrichment script basically allows us to brighten up the alert with a lot more of simplified data. So, if we actually look at the figure 1.1 here, so how it works is it takes the actual raw SCOM data going into the SCOM console, and in the alert view is where you would see all of your alerts come through. So the enriched side is where we will get certain fields which would be enriched with more simplified information so that anyone who may not be necessarily technical or may not know as such about a particular technology, the enriched simplified data will then be the best way to exactly understand what is affected, how it's affected, and more in terms of detail of the actual structure and the domino effect of what the alert could actually do. So it's also a way of understanding um, from what and how an alert was triggered as well. So it's all about seeing the not only just the end to end of how the alerts are actually raised, but also find the detail, even for the SCOM administrators, for example. So wanting to investigate exactly where the alert derived from. So that could be as far as the actual management pack, or it could be as far as the actual class or the actual class instance, which is actually affected. And sometimes with the default descriptions and the alert information which we may get in the actual SCOM console might not always make that very easy to detect. So therefore, the alert enrichment has a better way of filtering between false positives and real issues. As we have seen many of the time, we may experience things such as a config churn, or we may have a repeat count that just goes to absolute oblivion. And the best way to really understand how that is affecting us as well as the SCOM infrastructure, the alert enrichment is a great way of bringing all of that real data to life. And it's an easy analysis across different support for teams and stakeholders as well. So it gives a better structure and a better detail to everything in terms of understanding exactly where you are and where you stand in terms of the actual overall health state of your infrastructure. So a bit more detail on how the process works. So the stage one would be that the actual SCOM alert is then generated. You will then see that in the alerts view console. Stage two, the actual enrichment workflow will analyze the SCOM alert, and this is done by various bits of criteria that it is matched up against and baseline against. So if the alert does match the criteria that is defined in the enrichment workflow will then take those alerts, and then it will proceed with the correct enrichment, and it will populate the custom fields. So we have 10 custom fields which are sort of there for the taking in terms of the actual mapping of the enriched data, and this is what we take advantage of here. And other bits to cover about the actual alert enrichment process is they work very well in conjunction with integrations with other technologies. So, say for example, you might have an integration with something like ServiceNow, for example. You may already have an integration that already forwards alerts from SCOM all the way into ServiceNow to create them as um, incidents or tickets, for example. Now, if you are utilizing, let's say, more of a custom form, then you can actually structure how the tickets and incidents would look in a technology such as ServiceNow, or even something such as the System Center Service Manager, for example. And all of those alerts you can then structure on, let's say, a custom form or a custom view, and then you can then populate them with more of the simplified information, so then it actually reads a lot more clearer and it's understood a lot easier by teams or such as support teams, first line support teams, so that the escalation process is a lot more clearer and a lot more to understand from those tickets when they are eventually triaged. So next is what information can be enriched. So we have a table here which actually shows all of the custom fields which we discussed earlier. But then we've also got things like the ticket ID, for example. Now there may be ways in which you can actually automate the actual ticket ID being populated depending on the method that you are using. So if you have integrations which let's say would be a semi-automatic approach, then it may just be a case of you manually putting in the actual ticket ID from whichever type of ticket logging system you might have. But then if you have more of an autonomous approach, then you can actually use criteria to actually obtain the actual ticket ID and then populate the actual SCOM alert that way in the actual ticket ID field. Then we've also got the owner field, which is also a very important field. With the right criteria, we can then specify exactly who would be responsible for that ticket. So that criteria could be anything from in terms of the actual the name of the alert or the actual affected CI in the alert, or it could just be maybe more specific information like the actual management pack that it derives from. It could be very specific type of criteria, which we will actually cover later on in the fields as well. So, and the next is also a very detailed part of when it comes to any type of alert enrichment, which is the alert mapping planning. So here is an actual a table template which I have used several times in many projects across various clients that I have, and this is a way of mapping exactly what information the business would want to see, and then we then structure out a workflow logic which is then the actual baseline criteria, which actually analyzes the alert. And then once that criteria is then passed, it then goes right onto the map field. So if we have a look at the very first one, so the enrichment value that we expect to have in the owner field, for example, is the AD user or group. So what we're saying here is we want the AD user or group to then be populated into the owner field of an SCOM alert ticket for when a certain criteria is then met. So that way we understand exactly who is actually responsible for that. So when we look at our business structure, we may have a structure in which already aligns certain users, or in this case, certain groups, to own very specific services in the business. Those services can be segregated by a technology basis. They could be departmentalized, but the point of the structure is that we actually use that kind of data and that information to then build the workflow logic. So that once we understand exactly which users and which groups are responsible for what, we can then lay out and define that workflow logic in the alert enrichment workflow. And once that baseline is then met, then all of that information would be added into the owner. So then that works very well in terms of the triage if passing over to other third-party integration systems, examples being such as Service Manager and also the ServiceNow system as well. Um, Next is the help desk ticket reference. So again, going to the same thing about the third-party system, being Service Manager or ServiceNow. So we could have the actual ticket ID of when an actual ticket is raised or when a ticket is actually created. So what we would do in this sense is that we would have a workflow logic that would actually look at the third party system or the integrated system in which you have, and then it would then be used to find out exactly the ticket ID of the actual alert which is being triaged, and then that SCOM alert can essentially be populated with the ticket ID. Now, as an example, you'd think, well, how exactly would you be able to relate the actual alert to the actual ticket ID that you'd have in a third-party integrated system? Well, one of the things we will cover a little bit further is if we take a look at the custom field 4, we have the alert ID, and the alert ID is a unique GUID, which is created every time an alert is actually created in SCOM. So that alert ID would then be used as a reference to create any kind of alert in a third party integrated system. So then we would then interrogate that third-party system with that alert ID. That would allow us to then find the actual ticket ID, and then that ticket ID can essentially be passed back to the SCOM alert and then be populated with that information there. So then in the next field, we have the custom field one. So here, for example, we have the alert source. Now, the alert source, how I defined it is we may actually have more than one monitoring solution. We may not only just have SCOM. We may have things such as SolarWinds. We may have Splunk, What's Up Gold, even tools like Nagios, for example. Um, we can have various kind of tools, and we may even have integrations in place where alerts could then be forwarded onto SCOM, for example, and that would be a solution that would provide sort of a single pane of glass so that all of our monitoring is then held in one centralized area. So the point of this custom field is to actually analyze and understand where each alert comes from. So if we actually have triage from the other side where we could have different alerting tools, then we want to actually know exactly where that actually SCOM alert came from. Of course, the obvious place would actually be SCOM itself, but then we also want to find exactly and definitively know exactly where an alert came from. And that is the importance of custom field one. So majority of the time you may find that it would come completely from SCOM, but then we also want to find details and trails of where exactly the alert came from if it came from anything other than SCOM as well. Okay, so the next field is custom field two. So in this example for the alert mapping, we go with the actual category of the alert. So how I would define category, I guess it would be more, I guess, on the technology which is affected. So by having a workflow logic criteria such as investigating the actual the object class, for example. So let's say, for example, we have something that derives from the SQL side, for example. So let's say a SQL server is has an alert which puts it into a critical state, for example. That SQL server could have very business critical databases, for example. So that category would then structure it to know that that is a SQL based alert. But then what we also want to do is we also want to define uh, what kind of issue it actually is. So in this case, it would be labeled as an actual fault. So if we have an issue with a database running out of space, that would be deemed as a serious SQL fault. So that is the basis of how custom field 2 is strategically done. But the alert mapping planning table is really just to sort of give a baseline idea and a template on how you would actually structure the overall alert enrichment. So the next one we have here is for custom field 3. That is for the actual service offering. So I've defined service offering as, I guess, the name of I guess, an area of the business that would actually be affected. So we may have servers, let's say, for example, will stay on the SQL, for example. The SQL server we know as being a database server, but those SQL servers might belong to a specific area in the business. It might relate to a specific project. It could be defined in any kind of area and could look after anything. So what we want to do is if we actually have servers that are defined in specific areas of the business or specific areas in the project, we want to know exactly the responsibilities of that server. So once we actually understand where it belongs to, we can define the actual name of the actual service offering it actually belongs to as well. So the structure there would be to say, for example, if this SQL server, I guess, let's say by its name, let's go by its naming convention, let's say, or let's say you have a CMDB, for example, and then that particular server is then mapped to a particular service offering or a particular business offering. We will say, well, if this particular server um, is in this particular business offering or this particular service offering, then we want to populate custom field 3 with the name of that specific business offering or that specific service offering. And that would then be part of custom field 3 because these bits of information we might not necessarily have in a management pack by default. If this is a management pack that we would download from Microsoft, it may come from a management pack which you actually define yourself. If you are creating a custom management pack, for example, then perhaps you can actually have this information populated in the description. You might actually even have it in the alert name, or you may even have it defined in the actual custom fields by default anyway. But the point of the alert mapping is to create the actual workflow so that this is actually done in an automated way. So next we have the alert ID, which we covered earlier in the help desk ticket reference. So the alert ID being the unique GUID that is created every time a new alert is generated into SCOM. uh, we would then read that information on the actual raised alert, and then that would be populated into custom field 4. And this bit of information is quite key. So this is almost defined as say a key value, for example, because this is really the real unique identifier in trying to find any alert. So for example, we could be trying to find an alert, let's say through its SQL database. We could be trying to find it through its PowerShell module, or going through the PowerShell module via the SDK, or we may even have other integrations within our SCOM environment which might actually utilize the actual alert ID also as its key value as well. As we know that there are a lot of alerts that, even whether there is a config churn or an alert storm or not, we know that the only thing that would actually separate alerts that could have duplicate names would be by its alert ID. So this alert ID is actually very important when it comes to the alert mapping planning, because without it, we wouldn't be able to easily define or understand and tell between specific alerts if they have any duplications within their data. But that's the only piece of data that you can't duplicate. And if there is a duplication in your alert ID, then I would probably say there would be some serious SCOM issues there. But that's pretty much the idea of custom field 4. So then moving on, we go on to the next table, which goes through further additional mappings that we will cover. So the next part is the management pack that will be defined in custom field 5. So why is this information important? This information is important because for example, there are a lot of management packs that are structured as management pack families. You might not necessarily have a management pack that contains, let's say, every single monitor and every single rule and every single type of object defined in just one management pack. You may find that there are a lot of management packs that are defined in several pieces. So you might have one like the actual management pack library, then you'd have one for discovery, and then you'll have one for monitoring. And then if you take, let's say, the SQL management pack family, for example, you may have ones that will be defined by replication, and then databases, and then presentation. There could be many, many different factors. So when you actually see an alert generated, you might not necessarily know exactly which management pack it came from. You could have a pretty good guess, but then it might not be very easily identifiable. And this is the reason for custom field 5. So for example, if I wanted to look more specific on a monitor or rule to understand exactly not only which management pack it came from, but if I want to know the actual structure or how it's defined, how the monitor works or how the rule works or what it references, um, the best way to do that is to actually understand which management pack it actually came from, and this is what this actual map field does. So the management pack is easily stood out and understood. This is great for SCOM administrators that would utilize this information for specific scenarios which I've just mentioned. So the next one is the custom field 6. So this is the CI object type. So how we define the object type is, so if we have an alert that is raised, and let's say it for a specific Windows computer, for example, um, and that alert was based on a let's say free disk space, for example. So let's say we'll go with the system drive, we'll go with the C drive. Let's say it's uh, less than 5%, and it is in a critical state. So the CI object type in this case would be the actual drive which is affected by the actual space alert. So yeah, this information is actually defined in the description or the alert information already. But in this case, because we've also got other custom fields in conjunction with the actual enriched data, having this information easily seen also actually provides great detail as well, because when we come to actually defining another process for easily laying out all of our simplified data for it to be easily readable and identifiable, we want to actually bring this information along so that it actually works well in unison with the custom fields that we have as well. So that is the idea between mapping of the custom field 6 with the CI object type. Next one would be the CI name. Um, so here, this is basically identifying the actual principal name of the actual alert raised. So there are some alerts where you might not actually see the actual CI name that's affected. It can sometimes be overruled by the actual the object name, for example, or the object type, depending on how the actual management pack is actually structured. So in this case, we want to also bring this along in our custom fields as well. So this is a great piece of information that we can have for our custom field, and we've put this down as to custom field 7. And the next part is then the severity. In a lot of organizations, we have severity based on something like P1, P2, P3, and then all the way down to P6. So P1 being the most highest priority and the most business critical type service severity. And how do we define this? So this is probably requires even further mapping itself because of the actual criteria that could be met. I mean, we might have obvious servers that you would, I guess, count as a P1, let's say a domain controller going down, or let's say an actual physical server that would hold all of your virtualized platforms going down. Those areas could be extremely disastrous to your business. So you could easily argue that those would be P1s, but then we have to take into account other areas. So it could be the specific service or business area that could be affected. It could be the actual type of server. It could also be any bits of information that could actually be affected. So in this case, we want to structure the actual workflow logic to say if it meets all of these criterias, then we would output a specific severity in this case, and that is how we would define the actual severity between an actual P1 and a P6, and then that essentially goes into custom field 8. And next is then the repeat count. Um, so the repeat count is how many times the actual alert re-alerts again and again, and then that is then simplified into the actual repeat count statistic. Yep, you can see this information in a column view in the alert view as well. But then again, when it comes to simplifying the data and working with all of the custom fields, we want to bring this information again as well, because it's actually good to see how many times an alert is actually repeating itself, because that can also identify the actual alert storm or a config churn which is actually happening. So in that case, we want to bring that information along as well. Repeat counts can also be very incremental as well. So we want to also have a interval which is part of the actual alert enrichment workflow that would also regularly update the repeat count so that we make sure that the information between SCOM and if you are utilizing a third-party integration system such as ServiceNow or Service Manager or any type of bespoke tool that you choose to use, they are in sync together in terms of all of the information there. And then the next part is then the primary management server. So this is actually defined quite early on, which we will actually show a little bit more later on. So the primary management server being the actual SCOM agent that's actually being monitored, which actual management server is actually looking after that. And that is also important as well because we may have multiple management servers. They may be spread out, maybe in different resource pools. They may also be set up to have a failover as well between a primary and a secondary as well. But overall, if there are any kind of issues that happened with that managed SCOM agent, we want to be able to identify which management server is its parent. And that is also defined in custom field 10 for its mapping. So this table overall gives an actual idea and a structure on how you would do the alert mapping planning exercise. So this is really the brains and the overall logic between um, not only just your business, but then how you would define the actual alert enrichment workflow and how it would actually work for you. And this table gives a good idea as a guideline on how you would define it, and also gives a great outline to the actual demonstration, which I will provide on how that actually works as well. So if we go to the next page, so this is then the failover for the alert enrichment workflow. So how this works is how do we want to actually make sure that the alert enrichment always continues on and always runs no matter what in terms of, let's say, a disaster scenario in which a management server goes down. So how we avoid this is that we actually make sure that the alert enrichment workflow is aimed at a resource pool and not just at a single management server. Because if we have it just as one management server, for example, we would have a single point of failure. So if that management server went down, then that means the alert enrichment stops completely as well. And then that can have a domino effect on every other service that you actually provide in the business. So what we do here is we actually would define it to the default resource pool, which should contain all of your management servers depending on how many management servers you actually have. So if, let's say, management server 1 was to go down, then it could easily fail over to management server 2, and then vice versa. Management server 2 goes down and go back to management server 3. So once the alert enrichment workflow actually moves over to a different management server, it won't necessarily fail back unless you was to purposely force the actual management server to go down, and then it would then randomly pick the actual the best one between them in this case. But in most cases, the alert enrichment should work on the first management server, or whichever one is actually holding the RMS role in most cases as well. But then that can also be quite randomized as well. So next, we're going to go a little bit further into the actual enrichment workflow and how this all works in pieces. So this is the actual script logic that goes in the background. So the first part is the actual log file is then formed. So how the log file works is it is created as a .log file. um, it will go ahead and start making a few lines to say that the actual alert enrichment process is actually started. What it will do is it will actually investigate which drive is actually the best, and that is actually defined by the actual free space defined on the actual drive. So in some cases we have C as a system drive, and then the D drive may actually be the actual specified drive which we actually have SCOM installed on. So whichever one actually has the free space, and I would like to think that that one would actually have the best amount of free space, then the actual alert enrichment log file would then be created there. The next steps, it would be to actually formulate a connection to the SCOM environment by connecting to its actual PowerShell module. Once that has worked and then succeeded, it would then go to obtain the actual SCOM server that it's actually connected to. And then the other intelligent part is that it will also pick up the environment. So this is a structure that I put in my alert enrichment template. So say for example, we have a dev environment, we have a pre-production environment, and we also have a production environment. So if we want to have an alert enrichment process, to work amongst all of those, then what we can do is we can actually have criteria defined to say which environment are we in. If it's in a development environment, then in the log file we will actually state, well, we are connected in the dev environment, we're in the pre-production, we're in the production environment. So this can work very well depending on how all of your environments are integrated together. This is a great way to sort of show some more understanding in the logs to actually define and find out exactly where you are, server wise and also environment wise as well. So the next part is then the enrichment preparation. So one of the first things it does on the next phase is then it investigate which alerts need to be enriched. So what it will do, it would go through all of the alerts that would be, let's say, blank in all of their custom fields. It will actually go through them by each custom field, but overall, every custom field would actually be looked into, and all of the ones that show as blank in all of their enrichment mappings, they are then the next ones in line to be enriched by the overall enrichment workflow. So all alerts which are in a new resolution state are the ones that would actually be defined in this case. So you can actually change this if you either want to enrich alerts that are in a different resolution state, or you can even have criteria in which may want to enrich the alerts and then set a different resolution state to say something like new enriched, for example. If you wanted to define a different criteria on how you would actually say that the alert is actually enriched, not to look at this one anymore. But how this is structured is that if the actual custom fields are blank and if there is an error on trying to get certain information for whatever reason, once the alert enrichment actually resumes, it will look back at that blank field and then it will repopulate. Of course, if any information was to change, then that can also be overwritten as well. So say for example, repeat count is a very incremental piece of information that would actually be written over in this case from the enrichment workflow as well. And then the next part is the setting of the primary server sources. So if we think back to the alert mapping process, we actually had custom field 10 as being the primary management server source in terms of just the management server parent, but then this also looks after where the actual alert originated from as well. So those fields already get populated quite early on in this specific preparation phase. And then the next part is then the overall enrichment process. So here we look at the alerts currently have no enrichment, so everything from custom field 1 all the way down to custom field 10. We also have the ticket ID, and then we also have the owner field as well. So a specific user or a specific group. If those fields are blank, then they are defined as no enrichment. So then next, we look at the criteria baseline, and then we map that to the alerts which have a new resolution state which also have blank custom fields. And then if they actually pass the actual criteria and that's matched, then we go ahead and then we look at the alert custom fields, and then we should see that they are all enriched, and then they are showing in the actual SCOM console as well, which I will show a little bit more in the demonstration that we got coming up later. And then the actual log file as well will show all of the information of all of the alerts that it actually has enriched, but it will also show you a list of every single alert that is not enriched as well. So if you have alerts that don't actually meet a certain criteria, then it will outline every single alert, not only that didn't get enriched, but it will also show you which specific fields didn't get enriched as well. And then that is pretty much the alert enrichment workflow from end to end, from beginning all the way to enriched, or in some cases maybe not enriched. um, so how do we actually get this workflow to always keep running? So we would define it in an actual management pack. So this is the actual management pack fragment, for example, here. This is defined in a custom based rule. We've got it defined here to run every 300 seconds, which translates to 5 minutes. We have the alert enrichment, which is in a PowerShell script, which will actually be ran every 5 minutes. And this is actually how we keep the actual alert enrichment always going and always ticking. And then if we also look here where the target is, we can see the all management server pool. So this is the resource pool which we mentioned earlier in the failover slide. And this is how we actually make sure that the alert enrichment workflow is always running all the time. And no matter which management server was to drop, we would always ensure that the alert enrichment workflow is always running all of the time. And so now we will go into just a quick demo just to give an idea exactly on how everything works. So here is the actual Visual Studio, so we can actually see the same fragment which I actually showed earlier. And if we go to the alert enrichment script here, so this is the actual PowerShell script overall. This section here is the log file structure which we mentioned earlier in the slides. Um, how we actually create the actual timestamps. We find the actual drive with the most space. We then define a log file here. We also check to make sure that the log file actually exists, and if not, then we create it. We also have definitions on the actual log size. So if it actually reaches a certain size, then we'd actually stop logging on there, and then we'd actually create a brand new uh, log file after that to actually keep things in continuation. Um, we also have information on how we actually connect to the SCOM environment. If there's any errors, then if there's any errors connecting to the actual SCOM module, then the actual alert enrichment will actually stop. All of this is actually defined and shown in the log files as well. Uh, yep, so the rest here is how we actually define the environment that is being picked up on. We see all of the alerts grouped. All of the alerts for that have no enrichment are all defined here. And then we actually have sections here that show how we write to the log file of all the alerts that will be enriched. And then we have further criteria here. This is the criteria section which we defined in the actual alert mapping size. So all of this bit is all of the structure and the logic on how we would actually baseline an alert that has no enrichment, and then the criteria it has to meet before it can actually be enriched. So that covers that side, for example. And then the next part is then we go to our SCOM environment here. So the first thing I will show here is, let's say, the alert enrichment. So we have the actual alert enrichment folder here. We've got the alert enrichment logs which are created here. If we go into the CM trace here, we can actually see all of the timestamps. We can see all of the information here. We can see all of the alerts that are actually going to be enriched, and we also can see the alerts that haven't been enriched as well. So this is working in real time at the moment. If I was to, let's say, let's pull up an old one. Uh, let's pull one in a text file. so that we don't actually have to go through that. So if I open this, so yeah, we can see all the timestamps here. We can see the alert enrichment folder already exists. We can see the log file is still in normal limits, meaning that it hasn't gone over 1 meg, so it will continue on. Um, we've then got further information such as the source environment. And then we can see here uh, the following alerts will then be enriched. And then we can see here are all the alerts that are going to be enriched. And these are the ones that have no enrichment as well. So we've got a good understanding exactly of which alerts are enriched and which ones are not enriched. And then the next part is then going into the actual SCOM alerts to actually see the actual enrichment take place. So if I go to the properties here, for example, we can see the owner here, the SQL team, for example, as it's a SQL based alert. We don't actually have anything in the ticket ID, but we can, this has room to put the ticket ID manually, or if you have more of an automated integrated system, you can easily pass that information over there to here. Then next, if we go into the custom fields, now we can see everything defined. So we've got custom field 1. We know exactly where the alert came from, which is the SCOM alert. We've got the category here, which is the SQL based alert, and we know that it's actual SQL fault. Um, we also have the information such as the actual service offering, which is the database services, just as an example sake. We also have the alert ID, which is our important key value. We have custom field 5, which is the management pack. So this is exactly where the management pack did the alert actually came from. Custom field 6 is then the CI object type, so we actually know what type of object it actually is, so we know which actual class that or realm it actually belongs to. Custom field 7 is then the actual CI name, so we know exactly which CI is affected. We've got custom field 8, which is our severity. In this case, we've labeled it as a P1. We've got custom field 9, which shows the repeat count, which has gone off 8 times. So that's not too bad considering that this environment hasn't been touched in a little while. And then we got custom field 10, which is an interesting structure in how I've done it. So we've it's been defined by the actual source of where the alert came from, and then it also has the name of the primary management server source, and then the last part is then the actual overall domain. So if you've got environments, let's say the development, pre-production and production have completely different domain names, then we would also see it in this bit of information as well. And that is then the end-to-end structure and idea of the alert enrichment workflow. I have a article on my website here in which you can actually download the management pack, both sealed and the unsealed, especially if you want to edit the script that controls the alert enrichment. The manager pack should already work straight away in terms of the actual fragment itself. So that's already defined by 5 minutes. You are free to change that as much as you want to as well. And you can customize the script and template as much as you like. Uh, Always good to actually structure and test it before you actually seal it or import it back into your SCOM environment, just to make sure that the actual logic and the structure works throughout all the time. And yep, you could download it here, and there's also a little guide as well on how to sort of download it and how to use it and how to edit it as well. So yeah, thank you very much for watching. um, I hope that this has been quite informative and gives another idea and another spin on how you can utilize a great mold of clay, being the SCOM monitoring solution. As I said before, SCOM can pretty much monitor anything and everything as long as you know how to use it. All it takes is just some thought and just some great creativity. I say, if you know PowerShell and if you know SQL, then you can do magical things with SCOM. And yeah, that's the alert enrichment workflow. Thank you very much for watching. Thank you very much.